Today we're going to talk about section 3.1 in our textbook. Section 3.1 is about quadratic functions. A quadratic function is actually part of a polynomial function. So a polynomial function of degree n is a function of the form with this general formula. So let's say a polynomial function is a function with many terms. Poly means many, and that's part of the many terms a function can have. So we use a p of x where we start with the a sub n x to the n. So since we don't know in the general form we don't know how many what's the degree of the n, we just say a sub n xn, and that gets all the way down to a1x plus a sub 0. But this a sub 0 is a constant term, and this an cannot be 0. So if this is 0, you just cancel out. You cannot have a polar function like that with that form. So there are many cases. There are special names for when n is a number. So let's say n is 0. If n is 0, we say constant function, and where the form is p of x equal to a sub 0, which is this part right here. If n equal 1, we look at the last two terms. It's a linear function. So think about y equal to ax plus b, where ax is the case, in this case, a1x, and b is a sub 0. That is a linear line. The other one we are familiar with is when it's quadratic. That means the n is 2. So it has to form some leading coefficient, some number, x squared plus bx plus c. So this gives you the quadratic form, and we usually write the quadratic form as x squared plus bx plus, and the graph is a parabola. It either opens up or opens downward, depending on how the graph is designed. So here's an example of function x squared. So this is my pure attempt at drawing a parabola. Since it's supposed to come down even more, the vertex is supposed to be create a parabola with form x squared has a vertex as 0, 0. That's where the both of the ends side meet. So you have this quadratic function x squared plus b plus c. If a standard form, it takes this form: a times the x minus h, the whole thing squared plus k. The h tells you the horizontal shift, similar to what we did in chapter 2. The k is vertical shift, it goes up or down. This a tells you if it's going to be stretching or shrinking of the graph. Now, if the a is positive, the parabola opens upward, and the minimum value is at hk. If a is negative, the parabola opens downward, and with the maximum value is at hk. So is my example of a parabola opening upward or opening downward. So let's look at the problem. We have this graph is given. What is a vertex? Well, vertex is where they meet, right? So, so you go this side and you have the vertex right here. So that's about halfway between 0 and 1, so it's 1 half. And the y value corresponding is negative 1. So because what is a maximum minimum value of f? The maximum minimum value you asked, you cannot have a maximum minimum value of the same. So since this parabola opens upward, it's a minimum value. And we say the minimum value is negative 1, and it only occurs when x is 1 half. The domain is all positive, all real numbers, right? It goes to infinity for negative side, positive side. The range is, well, from -1 all the way to infinity. So the value of y or f of -b/2a gives a minimum maximum value. So if you know actually your b and a, you could actually calculate the minimum maximum. So let's look at graphing the function. In here you could sometimes you have to work out these terms using completing the square. So this form over here, a squared plus bxc, in order to get to this form, we would take we actually separate the a and b and this. So you put it in this form. We factored a from the a squared by bx plus c. The next step is we take the half of this and square it. And whatever we did to one side, we had to do the other side. So that's how we do complete the quadratic function. So this is a general formula. So here's the problem. X plus f of x equal 2x squared plus 12x plus 15 in standard form. This is a standard form. What they mean by standard form is the standard vertex form. Find its x and y intercept, sketch its graph, and find the minimum maximum where it's appropriate. So first thing, we factor out 2. So you have 2 factor out. So x squared plus 6x and plus 15. Then we complete the square on this and you get this format. And whatever we do over here, we have to minus it. That's why we get 2 times that. So f of x is equal to of x plus 3 squared minus 3. The y-intercept equals to x is 0. So f of 0 is 15. 0 over here. X-intercept of case when y is 0. So in order to solve y is 0, we said f of x is 0. Then we use quadratic formula. So this is the quadratic formula. We plug in all the numbers, and you get x is equal to 3 plus or minus the square root of 6 over 2. Now, if we could actually convert to a decimal if you want. So here is the graph. When x equal to -3, that's the vertex. And that will roughly become about the uh, the 3%, maybe 3% minus square root. Okay. Here's another problem. Gene has 300 yards of fencing, okay, and wants to enclose the largest rectangular area as possible. Construct a function that gives the area enclosed as a function of the width of the rectangle. What is the maximum area here enclosed? What are the dimensions of the enclosed area? So it's asking multiple questions. So whenever you come up with questions like this, you had to break it down. So we know he has 300 fencing material, and he wants to know the largest rectangular area. Construct a function that gives the area enclosed as a function of the width of the rectangle. So this to find the area is a function of the width of the rectangle. Then we have to find the what is the maximum area or the dimension. So let's look at it. So let W be the width and L be the length. So you have right here rectangular shape, 2L's and 2W. And to find the perimeter of any rectangle is 2 times W plus 2 times L. So we know that the entire area he was enclosed, he has 300 yards of fencing material. The perimeter is 300. So we put the L as a function of the W. So 300 minus 2W divided by 2 is 150 minus W. And then we take that and put it in terms of as a function of W for area. So to find the area is L times W. So L is 150 times minus W times W. So you get 100W minus W squared, or we write as negative W squared has 150. you complete the square, you get this from over here, get added. So you will get at 75 squared and 5,625. The maximum area that he can enclose is 5,600 square feet, square yards. And it only occurs when the width is 75 yards and the when the width and the length is 75 yards. Because if you actually look at the formula for W is 150 minus W. Or if your width is 75, 150 minus 75 is 70. So the fence area is a square because these two numbers give you squared, the same unit, same measurement for another problem. X f of x equals negative x squared minus 4x minus 3 inside the form. That's a graph and find its minimum or maximum. One thing we could take a look at is this is a the x squared is a negative. So we know that in the shape, if the parabola, if you sketch it, it will shape downward. So then you see completing the square to your complete this. So you get x plus 2 squared plus 1. To find the y-intercept is 0, f of 0. So plug in 0 for this, you get negative 3. The x-intercept, you try to solve f of x equals 0. So negative x plus 2 squared plus 1 equals 0. So you will get negative 3 and negative 1. The vertex will be at negative 2 and 1. So the maximum value is 2 occurs when x is negative 2. And if you look at the graph, negative 2 and 1. I hope this may help you guys understand quadratic functions.